Hi, today I'm gonna talk to you about radio waves. But first, I'm gonna make a little intro on water waves. Also, it's very important for you to know this vocabulary. So, the words you need to know are hertz, frequency, amplitude, radiation, transverse waves, longitudinal waves, medium, constructive interference, destructive interference, and interference. So, first, what are waves? What are waves? In physics, a wave is a disturbance that transfers through matter or space, with little or no associated transport. Waves consist of oscillations or vibrations through a physical medium or a field around relatively fixed locations. There are two types of waves, transverse and longitudinal, which you can see at the left. There's various types of classification for waves: radio, electromagnetic, micro, infrared, visible, gamma, X-rays, ultraviolet, etc. Who discovered radio waves? Radio waves were discovered by scientist Heinrich Hertz. He developed the unified theory of electromagnetism in the 1870s and predicted for the first time the existence of radio waves. How do radio waves work? Electricity flowing into the transmitter antenna makes electrons vibrate up and down, producing the radio wave. Radio waves are a type of electromagnetic radiation mostly known in their use for communication. Everyday products that use radio waves can be a television, a radio, a phone, and more. Ways in which radio waves can travel differentiate. For example, they can travel through ground waves, sky waves, and space waves. It is important to mention that radio waves don't need a medium to travel. Cold War. Radio waves were used a lot after World War II. During the Cold War, there was also a radio war between the United States and Russia. Both countries used destructive interference so that messages would never reach their destination, resulting in the death of people. Mathematical equations used for waves are first the speed of a wave, which equals distance times time, and it's measured in waves per second. Then the second equation would be the frequency equation, which equals speed over wavelength, and it's measured in hertz. And the third equation is the wavelength equation, which equals speed over frequency, and it's measured in meters. Now I'm gonna do two labs, one explaining how a radio antenna works and the second one with one of the equations I just mentioned. Lab number one, finding wavelength. Let's say there's a radio station transmitting at a speed of 29,970 meters per second. Now, let's say they have a frequency of 100 hertz, so the wavelength would equal 2.997 times 10 to the power of 8 divided by the 100 hertz, and the resulting wavelength would be of 2,997 meters. Number 2. So a wave is sent by antenna to a receiver. When a wave arrives at the receiver antenna, they make electrons vibrate inside it. This produces an electric current that recreates the original signal. Now I'm gonna make a summary of what I talked about. How have radio waves changed the world? The discovery of radio waves has changed the world drastically since their detection more than 100 years ago. Their discovery allowed birth to one of the world's most important branches nowadays, electronics. Every electronic communications device uses radio waves. For example, smartphones, TVs, radios, computers, and more use them. They can also be used to transfer information through Wi-Fi, scan your body through an MRI, or even localize you through GPS. At the right, you can see how a globalized world is thanks to radio waves and how a MRI can detect diseases thanks to radio waves.